Hey folks, so we've got another video, this one from section 5.6. So if you'll pull out your notes for that section, I want to take a look at one story problem in this section. So if you'll go down to number 20, this is a story problem about bacteria growth. So this says that the concentration of bacteria B in millions per milliliter after X hours is given by, and then we're given an equation. The first thing I want you to notice about this is that according to our statement, according to our problem, it says that B is how much bacteria I have. And then if you read further, X is my time. X is in hours. So letter A says how many bacteria. If I stop right there, that means I want to find out what B is. In this case, this is my Y value. How many bacteria are there after 2.5 hours? Don't think too hard on this one, folks. If you know what the time is, all you have to do is plug that into X. So we need to find out what B of 2.5 is. Plug that into our formula, take out your calculator, plug it into the calculator, and then make sure you have a label on that. Letter B then says how many bacteria? Same question, only this time we're working with 8 hours. So it's the exact same type of problem. Plug in 8, put it into the formula, plug it into your calculator, and you're finished. I would mention this, if you're not getting the same number that I'm getting on your calculator, make sure that inside of your power, that the entire power is only in one set of parentheses. Use the time sign in between those two numbers. Otherwise, you will get a different answer than I will. Now let's go down to letter C. Letter C says, this one's a little bit more difficult. After how many hours will there be 31 million bacteria? Now, 31, this is going to be my B value. This is my Y value, and I'm working backwards to find out how many hours. I'm trying to find my X value here. So the first thing that I'm going to do is simply plug into my equation. 31 goes in for the B, and I don't know X, so I'm not plugging anything in for that one. In order to solve this, I need to get rid of that 1.33. So that's the very first thing I'm going to do is I'm going to divide on both sides by 1.33. Once I've divided on both sides, I know that those two 1.33s are going to cancel each other out. And I'll just be left on the right-hand side with my E raised to the 0.15x. Notice that the left side, I didn't even get a decimal for that. I'm just leaving it as a fraction for right now. I'll let the calculator take care of that. Now, right now, as I look at that, there's no way in the world that I can make my two bases alike. There's no way I can make my bases alike. So you remember that when you can't make your bases alike, you log both sides. So which log should I choose? Should I choose the common log or should I choose the natural log? And in this case, for sure, I'm going to be choosing the natural log because I have an E there. And I know that E's and natural logs undo each other. Now, when I'm looking over here at this right-hand side, please remember your logarithm property. It was one of the property number 2s that we went through. I'll write it down right over here for you. As long as you have like bases, logs and exponentials undo each other. And I do have like bases here. I have a log base E of E raised to the 0.15x power. So next thing that I can do is log base E of E to the 0.15x is just going to equal 0.15x. That's using that property number 2. Then the next thing, continuing to solve, we want to get X by itself. So we're going to divide on both sides by that 0.15. And now's when I can get my calculator out and let my calculator do the work on that. And so I get my calculator out and I'm going to come up with a number 20.9921. Don't forget about the fact that you need to have a label on that. So the question was asking about when will there be 31 million bacteria. After almost 21 hours, there will be 31 million bacteria. In this case, it was 20.99 hours.